This is in degrees. You can also write them in radians. 30 degrees means pi by 6. 180 degrees by 6 is 30 degrees or pi by 6 radians. 45 degrees is pi by 4. 60 degrees is pi by 3, pi divided by 3. 90 degrees is half of 180 degrees, so pi by 2. We know how to convert from degrees to radians or from radians to degrees. Now, what is the value of sine theta? What is the value of cos theta? And what is the value of tan theta? That's what we are going to write here. Sine theta, cos theta, and tan theta. If we know sine theta value and cos theta value, remaining values, finding remaining values is easy. If you know these three ratios, remaining three are of course reciprocals of these three. Okay. So what is the value of sine 30 degrees? That's what we are going to find out here. What is the value of sine 45 degrees, sine 60 degrees, sine 90 degrees? Similarly, cos 30 degrees, cos 45 degrees, cos 60 degrees, and cos 90 degrees. And of course, tan theta. You know, before we actually write down the values, you know sine theta is opposite side divided by hypotenuse, and cos theta is adjacent side divided by hypotenuse. Find out the ratio of these two. Sine theta divided by cos theta is equal to y divided by r divided by x divided by r. So r in the denominator get cancelled. What do you get? The ratio is equal to y divided by x. Look at y. What is y? Opposite side of angle theta. What is x? Adjacent side of angle theta. So opposite side divided by adjacent side is called what? Tan theta. So sine theta by cos theta. Sine theta divided by cos theta is equal to tan theta. This is one relation between these three ratios. The relation between these three ratios is this. Sine theta, cos theta, and tan theta are related by this equation. So if we can find sine theta values and cos theta values, if you can find sine theta values and cos theta values, you will know tan theta values from this relation. Sine theta divided by cos theta is equal to tan theta. So we only have to fill these two rows. Of course, if you write down the first row, second row is easy to find by using a trigonometric identity. We will derive later. But anyway, let's find out sine theta values and cos theta values for all these angles. You don't have to memorize this table. You don't have to mug up this table. It's easy to find the value of sine 30 degrees, 45 degrees, 60 degrees, and 90 degrees also. Let's see how. Well, I'm going to the next page. We will write down the ratios values for different angles theta here, and we fill the table in the previous page. Okay. So the first one that I'm going to do is sine 30 degrees. How to find the value of sine 30 degrees? For that, take a right angle triangle. We can also find cos 30 degrees. Take a, not right angle triangle, take equilateral triangle. In an equilateral triangle, we call this equilateral triangle because the sides of the triangle are equal. And similarly, angles between the sides are also equal. These angles are also equal. Sum of the angles in a triangle is 180 degrees. So each angle here is 60 degrees. This angle is 60 degrees. This angle is also 60 degrees. And here, this angle is also 60 degrees. Now, in order to find out sine 30 degrees, we need a right angle triangle to find the ratio. We need a right angle triangle. So what I am going to do is, I am going to drop a perpendicular from B onto AC. So what I am going to do is, I am going to drop a perpendicular from B onto C. So I will start at B. I will drop a perpendicular onto AC. Let's call this foot of the perpendicular with the name D. Now look at the triangle ADB. This is a right angled triangle. This angle here is 90 degrees. Since this angle is 90 degrees, in this right angled triangle, angle B, at this angle is how much? 30 degrees. So this perpendicular divides this 60 degrees angle into two angles. So this perpendicular is also two equal angles. This perpendicular is also angular bisector. This angle is 30 degrees, and in the other right angled triangle also, this angle is 30 degrees. Look at one of these two right angled triangles. Here, this is also right angle. Take the right angled triangle ADB or BDC. We want to calculate sine 30 degrees. In order to calculate sine 30 degrees, you know sine 30 degrees is what? Opposite side divided by hypotenuse. This is sine 30 degrees. Opposite side means opposite side of 30 degrees angle. So what is the side opposite to 30 degrees angle in triangle ADB? In right angled triangle ADB. In right angled triangle ADB, sine 30 degrees is opposite side of 30 degrees AD by hypotenuse AB. Look at the figure. If you look at the figure, in an equilateral triangle, this perpendicular BD divides the side into two equal halves. AD and DC are equal. So AD is equal to AC by 2. CD is also equal to AC by 2. AD is equal to AC by 2, CD is also equal to AC by 2. So AD is half of the side of equilateral triangle that we have drawn. AB is one side of equilateral triangle, AD is half of the side of equilateral triangle. So AD is half of AB, I can say. AD is half of AB. That means this ratio is equal to what? 1 by 2. AD is equal to half of AC. But AC, AB and BC are equal. This is equilateral triangle. In an equilateral triangle, the side AB, side AC and side BC are equal. AD is equal to half of AC. Means AD is also equal to half of AB. It means sine 30 degrees is ratio of these two sides. Ratio of these two sides is equal to 1 by 2. Cos 30 degrees is equal to adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. Let me call the sides of the equilateral triangle. The names are, this is R or A. You can use any name. We generally use the name A, so use the symbol A. So this side is A. This side of equilateral triangle is also A. The total side is also A. So this means this ratio is, these sides are A by 2. Let me call this vertical with the name Y. Adjacent side means Y. Hypotenuse means A. So this is Y by A. How do we calculate Y in terms of A? Use Pythagoras theorem. In triangle ADB, in triangle ADB. Use apply Pythagoras theorem. What do you get? AD square, sum of the squares of the sides, is equal to square of hypotenuse. AD square plus BD square is equal to AB square. AD square is A by 2 whole square. BD square is Y square. And AB square is A square. AB is A, the side of equilateral triangle. We are calling by the name A. So in this equation we can write Y square is equal to A square minus A by 2 whole square. Y square is equal to A square minus A square by 4. When you do the subtraction taking LCM, you will get 3A square by 4. Or y is equal to root 3 by 4 into A. Or we can write it as this is equal to root 3 by 2 into A. So cos 30 degrees is equal to what? Substitute this y here. We got y value root 3a by 2. Substitute root 3a by 2 in this equation. You will get cos 30 degrees is equal to root 3a by 2 divided by a. A gets cancelled. You will get cos 30 degrees is equal to root 3 divided by 2. This is the value of cos 30 degrees. And here we got the value of sin 30 degrees. So we got sin 30 degrees is equal to 1 by 2. Cos 30 degrees is equal to root 3 divided by 2. So let's substitute them here. Let us substitute them. We forgot to write 0 degrees here. Let me introduce the column 0 degrees also. Now we got sin 30 degrees is equal to 1 by 2. We got sin 30 degrees is equal to 1 by 2. So I write 1 by 2 here. And we also got cos 30 degrees is equal to root 3 divided by 2. So I don't remember these values. We can find these values using some basic concepts of triangles. Now tan theta, how do you find tan 30 degrees? Because the ratio sin theta to cos theta is equal to tan theta, tan 30 degrees is equal to sin 30 degrees divided by cos 30 degrees. So tan 30 degrees is the ratio of sin 30 degrees to cos 30 degrees. So the ratio of 1 by 2 to root 3 by 2. So when you find the ratio of these two, sin theta divided by cos theta, in the numerator you will get 1 by 2, in the denominator you will get root 3 by 2. So simplify this, you will get 1 by root 3. 1 divided by root 3 is the value of tan 30 degrees. 2 get cancelled. So tan 30 degrees is equal to 1 by root 3. And similarly, we can find sin 45 degrees, cos 45 degrees, tan 45 degrees. Similarly 60 degrees, similarly 90 degrees, and similarly 0 degrees. Let's do it for 45 degrees. So let's see how to find sin 45 degrees, cos 45 degrees, and tan 45 degrees. To find this, what I am going to do is, I am going to take an isosceles right angled triangle. Let's take an isosceles right angled triangle. An isosceles right angled triangle means this angle is 90 degrees. These two sides are equal. The sides AB is equal to BC. AB and BC are equal. Or these two angles are equal. because this is 90 degrees. Total angle is, sum of the angles is 180 degrees. Since this angle is 90 degrees, sum of the other two angles should be 90 degrees. So these two angles are 45 degrees and 45 degrees, equal angles. 90 degrees is divided into 45 and 45. So AB is equal to BC. Adjacent side of angle 45 degrees is equal to opposite side of angle 45 degrees. Let me call this side by the name R or A. X is equal to Y. And since X is equal to Y, R is equal to, root of X square plus Y square, Pythagoras theorem. Since R is equal to root of X square plus Y square and X is equal to Y, substitute X is equal to Y here. What do you get? You will get R is equal to root of X square plus X square, because Y is also equal to X. When you simplify this, you will get root of 2x square, or we can write it as R is equal to root 2x. So the value of R, the value of hypotenuse is equal to root 2x. Now, sine 45 degrees is opposite side divided by hypotenuse. Cos 45 degrees, adjacent side divided by hypotenuse. Tan 45 degrees, opposite side divided by adjacent side. If you do that, sine 45 degrees, BC by AC, opposite to this angle theta. This is the angle theta I am taking. Or take the other angle also, you get the same value, because these two angles are 45 degrees. These two sides are equal. Sine 45 degrees is opposite side by hypotenuse, which is x by root 2x. So what are we getting? 1 divided by root 2. This is the value of sine 45 degrees. Similarly, cos 45 degrees, adjacent side by hypotenuse, which is again same, AB by AC. AB is also x. You are going to get the same value for cos 45 degrees. Similarly, tan 45 degrees. Tan 45 degrees is the ratio of sine 45 degrees to cos 45 degrees. Tan 45 degrees is opposite side by adjacent side. Opposite side is equal to adjacent side. Opposite side and adjacent side are equal. So tan 45 degrees is equal to 1. BC divided by AB is equal to 1. Okay. So we got the values of sine 45 degrees, cos 45 degrees and tan 45 degrees here. Substitute them in the table. Put them in the table. Sine 45 degrees, we got 1 by root 2. 1 divided by root. Cos 45 degrees also, we got 1 divided by root 2. And tan 45 degrees is equal to 1. Similarly, you can find sine 60 degrees, cos 60 degrees and tan 60 degrees. Look at this equilateral triangle that we have taken. We are going to take again one more equilateral triangle. Let's take one more equilateral triangle. Cos 60 and tan 60. Alright, look at this equilateral triangle. Draw a perpendicular from this vertex to the opposite side, just like we did to find 30 degrees, sine 30, cos 30, tan 30. So this angle 30 degrees. In an equilateral triangle, sum of the angles is 180 degrees, so each angle is 60 degrees. The 60 degrees is divided into two equal halves, 30 degrees and 30 degrees. This angle is 60 degrees. This is the opposite side of angle 60 degrees. And this is the adjacent side of angle 60 degrees. And this is hypotenuse. ABD. This point vertex is C. So look at the right angle triangle ABD. We found the value of y using Pythagoras theorem. Look at this page here. we found the value of y. We got root 3 a by 2. X AD is equal to a by 2. Hypotenuse is a. So let's write everything in terms of a. So y, we got root 3 by 2 into a. X we got a by 2. Okay. Now we know opposite side value in terms of a, adjacent side value in terms of a, and hypotenuse also in terms of a. Now let's write down sin 60 degrees, cos 60 degrees, and tan 60 degrees. Sin 60 degrees, opposite side by hypotenuse. Opposite side of angle 60 degrees. So when you simplify, you will get sin 60 degrees is equal to root 3 a by 2. Similarly, cos 60 degrees. Cos 60 degrees is adjacent side divided by hypotenuse. That is a by 2 by a. So we are getting cos 60 degrees 1 by 2. Cos 60 degrees value is 1 by 2. Here also, this is just root 3 by 2. No e. Sin 60 degrees is root 3 by 2, cos 60 degrees is 1 by 2. Tan 60 degrees, you can find the ratio of these two. You know, tan 60 degrees is sin 60 by cos 60. Or tan 60 degrees is opposite side by adjacent side. Okay. Tan 60 degrees is opposite side divided by adjacent side. You will get root 3 a by 2 divided by a by 2. When you simplify, you will get tan 60 degrees is equal to root 3. Now we found the values of sin 60 degrees, cos 60 degrees, and tan 60 degrees. Let's fill these values in that table. This value we got root 3 by 2, sin 60 degrees root 3 by 2. We got cos 60 degrees 1 by 2. And we got tan 60 degrees is equal to root 3. Now let's write down the values of 0 degrees and 90 degrees. Sin 0 degrees, cos 0 degrees, and tan 0 degrees. Similarly, sin 90 degrees, cos 90 degrees, and tan 90 degrees. Well, to find 0 degrees and 90 degrees. Alright. Take a right angled triangle. Take any right angled triangle. So here, this angle is 90 degrees. If I say this angle is theta, the other angle is, of course, as you already know, 90 degrees minus theta. We are calling the horizontal side with the name x, the vertical side with the name y, and the hypotenuse with the name r. As theta decreases, as theta becomes smaller and smaller, if you look at the opposite side y decreases. As theta decreases, the opposite side y decreases. You can see that. Okay. Or let's take a circle in order to understand how these angles are changing. What happens inside the circle? This is x-axis. Draw a vertical line passing through the center of the circle. It is y-axis. This is the center of the circle, x-axis and y-axis. In the first quadrant, draw a right angled triangle. This is theta. Look at y. Decrease angle theta and draw one more right angled triangle. This is y. Angle theta has changed, decreased. Decrease angle theta and draw one more right angled triangle. Decrease further and draw one more right angled triangle. So as theta decreases, the opposite side of theta also decreases. Y decreases, decreases, decreases. When theta becomes 0, y also becomes 0. So look at this right angled triangle. With very small angle theta. When theta is very small, y is also very small. X comes very close to hypotenuse. So when theta becomes 0 degrees, y becomes 0 degrees and x becomes r. X and r. When theta becomes 0 degrees, when the vertex B falls on point A. So when theta decreases and B comes close to A. So what happens here? When B comes close to A, x becomes equal to radius and y is equal to 0 degrees. So for theta is equal to 0 degrees, y is equal to 0 and x is equal to r. So here I can write for theta is equal to 0 degrees, x is equal to r and y is equal to 0 degrees. You know, sine theta is equal to opposite side by hypotenuse. When opposite side becomes 0, sine theta also becomes 0. So sine 0 degrees is equal to 0. Sine 0 degrees is equal to 0. Because when theta becomes 0, opposite side becomes 0. The ratio becomes 0. And what about cos theta? Cos theta is equal to adjacent side by hypotenuse. Since cos theta is adjacent side by hypotenuse, adjacent side becomes equal to r. You know, cos 0 degrees is equal to r by r. X becomes radius of the circle, x becomes hypotenuse. Theta is equal to 0 degrees. So what are we getting? Cos 0 degrees is equal to 1. So tan 0 degrees is the ratio. Sin 0 degrees by cos 0 degrees. So tan 0 degrees is also equal to 0. The value of tan 0 degrees is equal to 0. Okay. Similarly, we can find for 90 degrees. For 90 degrees, draw one more circle here. Alright, look at these two axes, x-axis, y-axis. Now draw a right angled triangle. When you draw a right angled triangle, theta is high, theta is close to 90 degrees. Let me call this point O, this point, this side is y, opposite side is y, hypotenuse is r, adjacent side is x. As theta approaches 90 degrees, what is happening to y? Y is increasing. Look at the side x, x is decreasing. Okay, take one more right angled triangle. Look at y here and x here. Right? So here theta is changing. When theta increases, y increases and x decreases. So when theta becomes 90 degrees, x becomes 0 and y becomes equal to r. When theta becomes 90 degrees, imagine this right angled triangle where this point is going towards this point. So y is approaching r. So when theta becomes 90 degrees, y becomes equal to r. So so we can say for theta is equal to 90 degrees, x is equal to 0 and y is equal to r. Now let's write down the expressions for sine 90 degrees. You know sine 90 degrees is opposite side by hypotenuse is equal to 1. Y becomes equal to r. So 1. Cos 90 degrees is adjacent side by hypotenuse, but adjacent side becomes 0 for theta is equal to 90 degrees. So cos 90 degrees is equal to 0. tan 90 degrees, sin 90 degrees by cos 90 degrees. So infinity, tan 90 degrees value becomes very, very high. So we found the values of sin 0, cos 0, tan 0, and also sin 90 degrees, cos 90 degrees, and tan 90 degrees. Let's substitute these values in the table that we have drawn. So we got sin 0 degrees equal to 0, cos 0 degrees equal to 1, and 0 degrees also equal to 0. And sin 90 degrees we got 1, we got cos 90 degrees 0, ratio 0, and tan 90 degrees equal to infinity. So for these values of angles, this is how we can find sin theta, cos theta, tan theta. If we know sin theta, cos theta, tan theta, we also know their reciprocals, right? Okay. Let's write down the values of their reciprocals also. So what is the reciprocal of sin theta? Cosecant theta. Reciprocal of cot theta? Secant theta. Reciprocal of tan theta? Cot theta. Cosecant theta is reciprocal of 0 for 0 degrees, infinity. Secant theta 1 because cos 0 degrees is 1, secant 0 degrees is also equal to 1. Cot 0 degrees is equal to infinity. Okay. Similarly, for 30 degrees, cosecant 30 degrees is equal to 2. Secant 30 degrees is equal to 2 divided by root 3, reciprocal of root 3 by 2. And cot 30 degrees is equal to root 3. Okay. Similarly, cosecant 45 degrees is root 2. Secant 45 degrees root 2. Tan 45 degrees is equal to 1. So cot 45 degrees is also equal to 1. Similarly, we can write the other values also. 2 by root 3, 2, 1 by root 3, and 1, infinity, 0. This is how we can find the values of different trigonometric ratios at different angles. You can also find sin 15 degrees, cos 15 degrees. You can also find other angles also. But finding these angles using the triangles is easy. That's why we did these angles.